Hello all. So today we are going to discuss how to plot Bode plot for a given problem statement. So let us consider a problem which is 10 divided by s into 1 plus 0.4s into 1 plus 0.1s. So the very first step is that we need to check what all the parameters are there, whether they are there in this format, that is 1 plus s into t format. So for example, if we consider here, we can find out that it is 1 plus 0.4s, so which is in this format. And also we are having one more variable, one more parameter, which is 1 plus 0.1s, so this is also in this format. So that's why this given problem comes under the given condition. But what if we are having something like this, 2 plus 5s? Suppose if you are having something like this, 2 plus 5s. Okay, in this condition we find out that this 2 plus 5s, whatever is there, it is not there in as 1 plus st form. So what we should do, we have to take this 2 common. So if I take this 2 common, it will be 1 plus 5 by 2s. In this if it is 3 plus 6s, I need to take 3 common, so it will be 1 plus 2s. Suppose if you have this combination, that is this combination, then we have to take 2 common from this and 3 common from this, so that 1 plus 5 by 2s and it is 1 plus 2s. So that will come under into the given condition, that is 1 plus st. So the given problem statement has to be converted into 1 plus st form. But anyway, for us it is there as the given, it meets the given condition. Yeah. So the second step is that we need to replace s with j omega term. So when we replace that, it will be g omega t. Okay, g omega. So we can find out that j omega is there. This s is also replaced with j omega, and this s is also replaced with j omega. So this is how the second step is, that we need to convert that s into j omega form. Right. So this would be the final equation when we convert that s into j omega. So after that, we need to find out the magnitude, that is corner frequency. So how do we find out corner frequency? For that, we need to find out those sets which are into the format of 1 plus st. Okay, which are into the format of 1 plus st. So I find out this one combination and this combination. So after finding out that, we need to find out the corner frequency. So we find out that there are 2 combinations which have 1 plus st. So we will be having 2 corner frequencies, omega c1 and omega c2. So how do we find out that? So omega c1 is equal to 1 by 0.4. So the one number, okay, which is there with the j omega, okay, so because, okay, so that will be 1 divided by 0.4. So we will be having 2.5 rad per second. Okay, so the second one is second omega c2, so it will be again 1 divided by 0.1. so after taking that, it will be 10 rad per second. So we have to take the number which is with j omega term, right? So these two will give us the corner frequencies. Yeah. So after taking the corner frequency, we need to plot a table. Which will be having term. Then the second column has corner frequency, and the third column has slope, and the fourth column has change in slope. So what is the first term in this? The first term in this is 10 divided by j omega. This is the first term. So that I have put it over here. What is the second term? It is 1 plus 0.4 j omega. What is the third term? It is 1 plus 0.1 j omega. Right? So this is what. And the corner frequency, we know that corner frequency will come in only if it is in the format of 1 plus st. So as this term doesn't have 1 plus st form, so the corner frequency will be null for this. Okay. And for the second one, anyway, we have found out for this one omega c1 is 2.5, and for this one omega c2 is equal to 10. That we have done it in the previous slide. So after this, the critical part is to finalize what is slope. So the slope will be, suppose if it is 1, the term is, suppose if the term is 1 by s, suppose if the term is 1 by s, suppose if the term is 1 by s, then the slope whatever we have taken is minus 20 dB. Okay, so here also we find out that anyway we have substituted s is equal to j omega, right? So that means 1 by j omega is equal to how much? Minus 20 dB. So here also we find out that this j omega term is that the denominator. So that's why again the slope will be minus 20. Here also you will find out that the j omega term is the denominator. So here it will be minus 20 dB. Okay. So what is the change in a slope? So in the first term, okay, always the change in slope will be null because it won't be compared with any previous slopes. So it will be 0. But for the second term, okay, we find out that it is coming from minus 20 to, okay, again minus 20. So change in slope is minus 40. For the third one it is, okay, for the third one it is minus 40 because still here it is minus 40 change in slope, minus 40, minus 20. So the overall change in slope is minus 60 dB. Right? So this is how we find out, we need to fill this table. Yeah. So after this anyway we know that there are two frequencies, okay, two corner frequencies, omega c1 and omega c2. But with this we need to have two more frequencies, that is omega lower and omega higher. So omega lower, let us assume it as 0.1, and omega higher, let us assume it as 100. So in and all we'll be having 4 frequencies. So in and all we'll be having 4 frequencies. So after this we need to find out the gain magnitude of this, because we know that we have to plot frequency versus magnitude, right? Frequency versus magnitude. We know what is, see, these all omega L all will come under where? It will come under this frequency term, but we need to find out what is its magnitude. So to find out the magnitude for a given frequency, we have to use some formula. So for example, what is the first formula is? So to find out the gain, okay, so here as we want to find out the magnitude, so what could be its formula? The formula to find out the magnitude for a given frequency is 20 log, okay, divide into B by A. Okay, so this is the formula that we have to use when we want to calculate the magnitude for a given frequency. Okay. So now the same thing is being used. So to calculate the magnitude for this frequency, so we have to use A is equal to 20 log of 10 divided by j omega. This j omega is for this corresponding frequency, which is omega L, which is 0.1. So I have substituted here and I found out that it is 40 dB. Second one, omega c1, okay, to find out the magnitude for omega c1, again we have to use the same formula, that is A 20 log of 10 divided by j omega. Here j omega is, omega c1 is how much? Omega c1 we have found out that it is 2.5. So we need to use the same formula here. We need to use the same thing over here. So for this omega c1, what is we have? We have 2.5. So 10 divided by 2.5. So it is 12 dB. Right? So for the other frequencies, how to calculate the magnitude is, we are using some different formulas. So for omega c2, what is omega c2? We have it around 2.5. Okay, that's a corner frequency. It is 2.5. For 2.5 we have to use slope from omega c1 to omega c2, right? So slope from omega c1 to omega c2. So if I go here, I find out that just a minute, I'm just erasing all those things. Yeah, so slope from omega c1 to omega c2, that means from here to here, right? So from here to here. So in that case we have to check this change in slope. So that is omega c1. What is the change in slope at omega c1? It is minus 40. So we have to take that minus 40 here, right? So that is minus 40 into log of omega c2 by omega c1, right? Omega c2 by omega c1. So what is omega c2? It is 10 divided by 2.5 into the previous magnitude plus the previous magnitude, that is a of omega c1, that is 12. So if I do this, I will be getting it as minus 12 dB. Similarly, to find out the magnitude at highest frequency, I need to use slope from omega h to omega c2, right? So if you go to this omega h to omega c2, so what is that slope from this one? Okay, omega c2 to omega h. Okay, the next frequency anyway will be omega h only, omega h only. So for that, what we should use? We should use the change in slope of minus 60 dB, minus 60. So if I use this, I will be getting it as minus 60 into log of omega h by omega c2. So omega h is how much? 100. Omega c2 is 10, corner frequency, minus 12. This 12 is the previous one, from the previous one. It's a magnitude. So if I do this, I will be getting it as minus 72 dB. So then this has to be plotted where? This has to be plotted on semi-log sheet, wherein I can, on x-axis there will be frequency, right? On x-axis there will be frequency, and on y-axis there will be magnitude. Correct? So if you do this, you will be getting such a plot there. Yeah. But Bode consists of even a phase plot also. So how to go ahead with phase plot? To go ahead with phase plot, we need to convert this equation into phase. So how to do it? So there are three terms over here, that is 10 divided by j omega, right? So it is 1 divided by, as if it is 1 divided by s, or 1 divided by j omega, right? So if that is there, then it will be minus 90, right? So this one will be tan inverse of b by a. So this term will be b. Okay, so it is 0.4 divided by 1. So it is minus tan inverse of 0.4 divided by 1. Then the next one will be minus tan inverse of 0.1. It is b. Okay, this should be b and this should be a. So tan inverse of b by a. So b is how much? 0.1. A is 1. So it is this one. Right? Why it is minus? It is minus because this j omega term is at the denominator. Suppose if this j omega term at the numerator, then this won't be minus, this will be plus. If all the things are at the numerator, or if all the denominator things are at the numerator, right, then this would have been plus. Phi is equal to plus 19 plus tan inverse plus tan inverse of omega. As all the terms are at the negative denominator end, all j omega terms or s terms are at the denominator. So that's why what will happen is the phi or the angle will be negative. So after this we need to plot it. So we need to make a table which consists of omega phi. So if I keep on varying phi omega from 0.1 to 100, I will be getting different values of phi. So this has to be plotted on Bode plot. So this is a very simple example that has been covered in this video tutorial. So thank you for watching.